Welcome back to another video. I hope you're having a great day. Today in this video we are going to be talking about more linear equations, but this time with geometric formulas. Okay, so geometric formulas, there are some common formulas that you should know, and we're just going to talk about a few of those. And before we talk about those, I want to really talk about the difference between the measurements of area, perimeter, and volume. And so area, so no matter what the figure is, if it's a triangle, if it's a rectangle, the area represents the amount that is inside that figure. So it represents the measurement of how much space is occupied inside that figure, and this is for a two-dimensional figure. Now, the perimeter represents the amount around the outside. So the distance around the outside of the figure is the perimeter. So area represent what's inside, and the perimeter represent what's on the outside. So when you think of perimeter, you think of like the outside of something. So you're measuring the outside of the figure. Now you deal with volume when you talk about three-dimensional figures. So if I have a three-dimensional, like a can, the volume represents the amount of space inside that three-dimensional figure. So you want to make sure you know the difference between those, volume, area, and perimeter, and when you want to be able to use those. So now there are a few formulas that you should know or be familiar with that comes up a lot, and a few of them are, so first of all, when you're dealing with a rectangle, you have a length and a width, and so you have the area of the rectangle, which is given by length times width. So to find the area of the inside, you will multiply the length and the width together. When you're dealing with the perimeter of the rectangle, you would do twice the length plus twice the width. So basically you would add up all of the sides, and if you add up all the sides, notice you have two lengths and you have two widths. So you do twice the length plus twice the width. So that's your formula for perimeter of a rectangle. Now you also have a triangle. And the area of a triangle, or when you have a triangle, you have a base, which is the measurement of the bottom, and you also have a height, which is how tall the triangle is. And so to find the area of the triangle is 1/2 of the base times the height. That is your area formula for triangles. And then for perimeter, there's no set formula, but basically you would just add up all of the sides. Excuse me. Then you have a circle. So for circle, the area is pi r squared, and the perimeter is actually called the circumference, and the circumference is 2 pi r. And so that is, the circumference is actually the perimeter of a circle. It's another term which means perimeter of a circle. So these are some of your basic formulas that you see over and over and over, which you should be familiar with and should know. Now there's one more that involves finances, and it's called the simple interest formula. And the simple interest formula is I equal to P times R times T, where P is the principal, which is the amount of the investment, and R is the interest rate as a decimal, so that should be always a decimal, and then T represents the time, and that's in years. Alrighty, so this is your simple interest formula. I equal P times R times T. So these are some basic formulas that you need to know, be familiar with, and we'll see some of those in this section and in some of the examples we worked today. So let's look at some examples. Example 1 is just going to give us a little bit of experience of how to manipulate these formulas. And so what we have is we want to find the value of the remaining variable for A equal L times W. So remember, this is the area formula for a rectangle, where A is equal to 64 and L is equal to 10. So it gives us, so A is equal to L times W. It tells us that A is equal to 64, so I'll replace A with 64. It tells us that L is equal to 10, so I'll replace L with 10, and then it wants us to find the value of the remaining variable. So the remaining variable will be W, which is the width. And so what we will need to do is solve this equation. Get rid of this 10 so that W can be by itself. This is 10 times W, so in order to get rid of it, we will divide. So W is equal to 64 divided by 10, which comes out to be, W is equal to 6.4. So your width will be 6.4. And so that's how you work that problem. Let's look at another one. For example 2, Kathleen's backyard is in the shape of a rectangle. The length is 5 meters less than twice the width. And the perimeter is 80 meters. So we want to find the dimensions of the yard. Okay. So we read the problem. Now I want to draw a picture because it tells us that her backyard is in the shape of a rectangle. It also tells us the perimeter. So I know I'm going to be using the perimeter formula, which is 2W plus 2L or 2L plus 2W. It doesn't matter which order you write it in. It tells us that what the perimeter is. The perimeter is 80. Yeah, the perimeter is 80. So I'm going to replace P with 80. But it also tells us that the length is 5 meters less than twice the width. So if this is my width, this is my length. It says that the length is, which is equal, 5 meters less than. So remember, whenever it says less than, that comes at the end. So that'll be minus 5. But what is it less than? Twice the width. So the length is 2W minus 5 because it's 5 meters less than twice the width. So since we know what L is, and because this has two variables in it, I can't solve it. I can only solve the equation, one equation, when it has one variable. So what I'm going to do is I'm going to replace L with 2W minus 5. And now I have only one variable in here, which is W, and now I can solve for W. So I get 80 is equal to 2W plus, I'm going to distribute this 2 because it's outside of the parentheses, which will make it 4W minus 10. Then I'm going to combine my like terms, 2W plus 4W, which is 6W. So that becomes 6W minus 10. So now I need to get W on the side by itself. So I'm going to get rid of the minus 10 first by adding 10 to both sides. And I get 90 is equal to 6W. And then I'm going to divide both sides by 6. And I get W is equal to 15. So the width is 15, but it asks us to find the dimensions, which means it wants us to find the width and the length. So remember, the length is 2 times W, which we know is 15, minus 5. So that's coming from here. 2 times W minus 5. So 2 times 15 is 30. 30 minus 5 is 25. So the dimensions are 15 by 25. So you can write it like that. 15 by 25, or the length is 25 and the width is 15. So that's how you would state your answer. And you can go back and check it as well. But that is the solution to this problem. So let's look at another example. Okay, for example 3, we have another word problem, and it says the area of a sailboat, the area of the triangular sail of a sailboat is 126 square feet. The base of the sail is 12 feet. Find the height of the sail. Okay. So again, we have a triangular sail on the sailboat. So however you want to look at that, we got a boat. Draw my picture. It's a sailboat. We have a triangular sail. We know that the base of it is 12 feet, and we want to know what is the height. So, and it tells us that the area is 126 square feet. So area is equal to 126 square feet. But we would need to know the formula for the area of a triangle, which is 1/2 base times height. We know the area is 126, so replace A with 126. We know the base is 12. And so basically we need to figure out what is the height. So we'll solve that formula for height. So 1/2 times 12 is 6. So I'll combine those together, and that becomes 126 equals 6H. And then we'll divide both sides by 6 to solve for H. And H is equal to whatever 126 divided by 6 is, which is 21. So the height is 21 feet, and that will be feet because the area was square feet. So your height would be 21 feet, your base was 21 feet. And you can multiply those and divide by 2 to see if you get 126, but it actually works out. And that's how you would solve that problem. Let's look at another one. Example 4 involves angles. So what we want to do is we want to solve for the measure of each angle, and it gives us a 180-degree angle because it's a line, and it's broken up into 2 separate angles, and it gives us a value for each one or an expression for each one, and we have to figure out how much is each angle. So what we know about supplementary angles is that they add to 180. So I would write 3x minus 30 plus 4x is equal to 180. So when I add these two together, they should sum up to 180. And so now I just end up solving this equation. So combine my like terms, 3x plus 4x, and that's 7x. So 7x minus 30 equal 180. I need to get x by itself, so I need to get rid of the minus 30. And I'm going to add 30 to both sides. I get 7x is equal to 210, and divide by 7. I get x is equal to 30. So x is equal to 30, but that's not the measurement of my angle. My angle is found by plugging 30 in for x. So for this angle here, it's 4 times 30, which is 120 degrees. And for this angle here, it's 3 times 30 minus 30. 3 times 30 is 90. 90 minus 30 is 60. So 60 degrees. So my angles are 60 degrees and 120 degrees. And when you add those together, they do equal 180. So that's how you would solve that problem. I have two more examples that I want to work, and both of them involve just solving for a variable with an equation with a lot of variables in it. So basically, you just want to get that variable on the side by itself. So in this example, example 5, we want to solve for L and P equal to L plus 2W. So I just want to get L on the side by itself. So I need to get rid of everything that's not with L. So I'll get rid of the things furthest from L first, which is the 2W. So since that's a plus 2W, I'll subtract 2W. And so I'll get P minus 2W equal to L. So now I need to get rid of the 2. And that's 2 times L. So to get rid of multiplication, you would divide. So divide both sides by 2. So you end up getting L equal, and I'm just going to rewrite, well, I'll write it like this. So P minus 2W all over 2 equal to L. So there's different ways you can write that. You can say L is equal to P minus 2W over 2, which is basically the same. I just switched the sides that it was written on. But you could also break this up and say that's P over 2 minus 2W over 2. Because whenever you have one denominator, you could break the numerator up over and write it over that denominator. And then 2 over 2, those go away, which makes it P over 2 minus W. So this is one possible solution. This is one possible solution. I mean, they're the same. It's just two different ways you could write it. So that's how you would solve for L in this problem. All right, let's do one more example where we solve for a variable when there's more than one variable. In this last example, example 6, we want to solve for y in 2x minus y equals 7. So again, I want to get y on the side by itself. So I'm going to get rid of everything that's on this side. So I'll get rid of the 2x first. That's a positive 2x. So I'll subtract 2x from both sides. Those will go away, and I still have a negative y. And this will be 7 minus 2x. These cannot be combined because 7 does not have an x on it. So if they both had an x, then you combine them. But since they don't both have an x, you have to write them separately. Now I need to get rid of this negative. So this looks like a negative y, but that's actually a negative 1 times y. So I'm going to divide by negative 1. So that'll make this positive. But you will divide each of these by negative 1. So 7 over negative 1 and minus 2x over negative 1. So 7 divided by negative 1 is negative 7. And a negative divided by a negative is a positive. So that becomes a positive 2x. So you could write it as y equal negative 7 plus 2x. Or you could change the order, meaning put the 2x first and write that as 2x minus 7. So either way it goes, these both are correct. So negative 7 plus 2x, or since this is negative, if you want to put the x first, you could write it as 2x minus 7. So this is how you would solve for y by getting y on the side by itself. So it was a lot. I know it was a lot of examples. We worked 6 examples, but all of this was solving linear equations. So still sticking with the theme of linear equations, this time we just used some geometric formulas. So if you have any questions whatsoever, you can include them in the comments below and I will respond. Thank you for tuning in. If you haven't already, make sure you hit that subscribe button. Also, if this video helped you in any kind of way, make sure you hit the like button. And leave a comment even if you don't have any questions, and let me know if this is helpful or not, or give constructive criticism. But thanks for tuning in, and I will see you in the next video.